This is the fifth video on dilations in the transformational geometry unit. This one discusses distance from P to the vertices and something true about the corresponding sides. So turn to number 17 on the student PDF. We're going to follow that along. Press pause as needed during the video. So to TI-Nspire technology, let's click on Tools, Templates, and we're going to look at number 4, distance from P to the vertices. So Tools, Templates, 4, distance P to vertices. And so you'll notice that it's showing these dotted segments here and showing the lengths. So what we want to do is investigate the distance from P to here. Oh, let's go ahead and dilate it and zoom a little bit. There, we can see better. We want to make as many distances as possible to be whole numbers, and while we're doing that, look for patterns. So I've already got PA and PA prime whole numbers, so I'm not going to mess with those. So let's go ahead and try to put B somewhere. Oh, there's a nice whole number. And then C. There we go. So that worked out pretty well. So part B says to record these 6 lengths below and make a conjecture based on what you've observed. Press pause as needed. And so we place those values into part B. The conjecture, well, I think we'll hold off for now, but I think you've got it. So we're going to click on Next and Observe. So let's go ahead and do that. So back to the software, I'm going to click on Next, and notice it's giving me the ratios of PA prime to PA, PB prime to PB, PC prime to PC, and they're all 2, which we kind of knew. But let's go ahead and grab and move things, and you'll notice that the distances all change, but look at their ratios. So for part D, does this seem to validate our conjecture? It seems to do that. Part E says to change the scale factor to 3 and observe what happens, as what we just did. So let's try that. Notice I'm not resetting, I'm just changing the scale factor to 3. I will zoom out a little bit so I can see that, and notice these awful numbers are being divided, but the ratio seems to be 3 in each case. So I'll go ahead and pull things here. And no matter what the lengths are, the ratios seem to be 3. Similarly, we'll go to change the scale factor to half and see what happens. So changing the scale factor to a half. Pull this out a little bit. But notice that the distances ratio is 0.5, which is 1/2. So as you can see, the scale factor and the ratios, definitely a pattern there. So at this point, return to part G and answer those questions. Press pause. And there are our answers. For the second part of the video, we're going to look at number 18. We're going to observe the slopes of corresponding sides. So let's go ahead and follow those directions there. So we're going to go to Tools, Templates, and Slopes. Tools, Templates, and Slopes. We're also going to click on the I menu and click on Grid. We'd like to see the grid, and then click Done. And so it's showing the slopes of the sides. Let's go ahead and dilate with a scale factor of 2 and zoom. And you'll notice something here true about the slopes. It says grab and move the 3 vertices and continue to observe the slopes of corresponding sides and make a conjecture. So when I pull this over here, when I pull this over here, and I pull this, what seems to be true about the slopes of corresponding sides. Even if I pull P into a different spot, that doesn't seem to affect it at all. So if you haven't already, make a conjecture and then answer the question, what does that mean about the corresponding sides? The conjecture we came up with, when a triangle is dilated about a point with a scale factor of 2, the slopes of corresponding sides are equal. See that as we did that investigation. Now what does that mean when the slopes are equal? That implies that the corresponding sides are parallel to each other. Part C asks us to change the scale factor to a third and do a similar investigation. So I'm going to go ahead and change the scale factor to 1/3. And you'll notice the triangle got much smaller for the image, but the slopes here, again, appear to be the same, no matter what we seem to move. And here are the results right here. And finally, the summary. If we're given a triangle DEF is dilated about a point P with a scale factor of 4, name 3 pairs of segments that are parallel. Go ahead and press pause and answer the question and then resume. And here are the 3 pairs of segments that are parallel to each other. Please finish all exercises up through number 18. This concludes video number 5.